couple more items we need to add to vectors. Now that we know a little bit about them, I think they'll be a little bit easier to understand. That is the concept of equal vectors, parallel vectors, and scalar multiplication of vectors. So just a little bit. Equal vectors. Equal vectors are vectors that have the same magnitude and direction. Notice that equal vectors have to have the same magnitude and the same direction. Okay? Two cars, if they have equal vectors, that means they're going the same speed and in the same direction. Going the same distance in the same direction. Okay? Equal vectors. Same magnitude and same direction. Parallel vectors. Parallel vectors are vectors that have the same or opposite direction. Okay? Looks like parallel lines on the coordinate grid. If we were to plot those vectors, they would have the same slope. Yes, now that we know about direction, one might be headed in the opposite direction from the other. That direction would be 180 degrees opposed to the other one. Or they may be in the same direction. They may have different magnitudes, but they are headed in the same or opposite direction. So parallel vectors would be headed in the same or opposite direction. Another concept is called scalar multiplication. Now that you know what the term scalar means, or a single one-dimensional quantity, we can use scalar multiplication with vectors. In other words, multiply a vector by a quantity. Now, what would that quantity represent? You have a vector, you've looked at it, you know what a vector is, you know what vector you need, force vector or whatever else you need to make something happen. You look at it, you do your testing, you realize that you need a vector that's more, okay, than what you have. You calculate what that is, you multiply by your current vector by that, and it works. So scalar multiplication is we can multiply our vector by a unidimensional quantity. And scalar multiplication is used to change the magnitude of a vector. It does not change the direction at all. It only changes the magnitude. Okay, how is that done? Let's say we have vector A, which is 6, 5. All right, I want twice the vector A. So twice the vector A would be 2 times the vector 6, 5. And how do we accomplish that? We accomplish that by multiplying each one of the components of that vector by 2. So we would multiply 6 by 2 and get 12, 5 by 2 and get 10. That would be an increase, or we doubled the force or the magnitude of that vector. We did not change the direction whatsoever. We simply doubled the magnitude of that vector. If the wind originally was going, well, that would be 36 plus 25. That would be 61. So the square root of 61, which would be about 7.8, 7.9. So if the wind was going about 8 miles per hour, now it's going about 16, between 15 and 16 miles per hour. Okay? All we've done here is just doubled the magnitude of that vector. Now let's try another one with some negatives. We have vector B, which is 9, negative 15. I want to multiply that vector by 1/3. Okay, how do we do that? 1/3 times the vector B, 1/3 times vector 9, negative 15. How do we accomplish that? We multiply the components of that vector by 1/3. What's 1/3 of 9 is 3. What's 1/3 of negative 5? What's 1/3 of negative 15? It's negative 5. So we end up with a vector of 3, negative 5. What we've done there is we had an original, let's see, 81 plus 225. Let's figure out what that is. 81, 225. We had a vector of approximately 17.5 miles per hour, okay, in a certain direction. Then what we've done is we've basically taken that vector and reduced it by reduced it to a third of what it was, so it would be about 5.8 miles per hour. Okay? So this would be the use of scalar multiplication in order to reduce a vector, the magnitude of a vector. This would be scalar multiplication used to increase it. Again, I want to emphasize scalar multiplication does not change the direction at all. It simply changes the length of that vector or the magnitude of that vector. Increases the force, reduces the force, increases the miles per hour, reduces the miles per hour. All it does is change the magnitude of that vector. Three concepts: equal vectors. Vectors that have the same magnitude and direction. Parallel vectors. Vectors that have the same or opposite direction, 180 degrees out of sync, or in sync. They can be different magnitudes, different lengths, different miles per hour, but they're headed the same direction or in opposite directions. That'd be two cars coming at each other, okay, would have parallel vectors. They may not have the same magnitude, but they would, two cars on a highway, one on the northbound lane and one on the southbound lane would be parallel vectors, represent parallel vectors. Scalar multiplication, you can use that to change the magnitude of a vector, but it does not change the direction. And there's two examples of how to do that.